short-range rules. Because of Z sub 6 equals S2, all prime gaps must now evolve from various sequences of gaps which began life as sequences of various lengths of 4, 2, or their cousins 2, 4. That is, the gap structure manifests a handedness, and this is inherited by all future sets. All primes must now either be of the form 1 plus 6n, left-handed, or 5 plus 6n, right-handed. All the while, never allowing the possibility of ever having had 2, 2, or 4, 4 in any subsequence, except S1. For example, gaps of 8 began as 2, 4, 2, and gaps of 10 as 4, 2, 4. It is instantly apparent that gaps of 8 could never pair with themselves, nor could gaps of 10, while they could, however, pair together. Also, gaps of 8, or 2, 4, 2, could never pair with twins, and gaps of 10, or 4, 2, 4, can never pair with cousins. Every gap from now on, post S2, is of the form G sub j equals 6n, or G sub j equals 2 plus 6n, or G sub j equals 4 plus 6n for some n. If n is even, if its anchor prime is left-handed, then to the right is a right-handed gap, or it is right-handed, and to the right is a left-handed gap. Or if n is odd, if its anchor prime is left-handed, it has a left-handed neighbor to the right, or it is right-handed, and has a right-handed neighbor to the right. We also have the following rule: only different hands can touch. This protects us from ever seeing 2, 2, and 4, 4. We refer to these as short-range rules, or SRRs. Since every gap is even, we can enumerate the half gaps by the positive integers. Every gap will be made eventually, because S2 provides an infinite feedstock of what amounts to sequences of 2, 4, 2, 4, and so on, or 4, 2, 4, 2, and so on, of arbitrary length, and this successfully covers the integers. Given the SRRs, every possible pair will also be eventually constructed. It is unstoppable. Triples passing the SRRs will also be created, and fully cover every allowed triple of the integers. This is also unstoppable. It stops here by construction. Once we examine some sets of 4 gaps, we begin to see holes, or band locations, which pass the SRRs. For example, the sequence 6, 6, 6, 6 is banned, and this is readily apparent on inspecting the gap set of S3. Look closely. There is no way to construct it. Short of measuring them, there seems so far no obvious rule of what can be banned. Of course, You can't build constellations of 5 gaps on band subsets of 4 gaps. Yet we have clusters that would seem to meet all the previous rules for shorter tuples being unconstructible. This is because the distribution of the set of gaps is becoming lumpy and restricting long-range combinations of constellations. We are currently empty-handed regarding the possibility of predicting long-range behavior in this regard. A very cursory experimental observation suggests perhaps half of the sequences greater than 3 in length that pass the SRRs do not occur because they are unconstructible in some SM, and therefore unconstructible in all higher forms. We can trivially count the set of gap tuples banned by the SRRs. The probability a sequence of even numbers of length n survives the SRRs is about 2/3 to the n. This leaves an enormous number of possibilities, but it seems about half larger than 3 cannot be constructed. In our next video, we end our introduction to the S model by examining the nature of randomness. We show the gap distribution, for all its internal patterns, is fundamentally incompressible. For more information, please see the next lectures, or Google multiplication modulo n along the primorials with its differences and variations applied to the study of the distributions of prime number gaps.